Good afternoon, ladies and gentlemen. Hello, my viewers and the internet. Welcome back to the channel, Smart Traveler Memos. Today we are going to prove the equation of a circle. By the end of this lesson, you should clearly understand what a circle is, how its equation is formed, and why the equation is x squared plus y squared is equal to r squared. This topic is very important for mathematics, especially coordinate geometry. Let's begin. Proving the equation of a circle. Step 1. Definition of a circle. First, what is a circle? A circle is the locus of all points in a plane which are at a constant distance from a fixed point. That is, the set of all points in a plane that are at a constant distance from a fixed point. That fixed point is called the center, and the constant distance is called the radius, usually denoted by r. For this reason, we place the center at the origin O, 0, 0. Basic terms. Center H, K, or having the coordinates H, K. This is the middle point of a circle. Radius R, distance from the center to any point on the circle. Diameter, twice the radius, or 2r. Real-life examples: wheels, coins, plates, water pipe, water ripples, and so on. So, that is the diagram of a circle. Can you see the center as we have defined, and the radius. Step 2. Drawing the diagram. Draw slowly on a plain piece of paper, or follow the following instructions. Draw the x-axis and y-axis. Mark the origin O, 0, 0. Using a compass, draw a circle center O. Choose any point on the circle and label it P, X, Y. Join O to P. The line OP is the radius, so its length is r. Now drop a perpendicular from point P to the x-axis. Let it meet the x-axis at point A, x, 0. And all this information is in the diagram there. So as a student or any member of the internet, you can easily follow those instructions and come up with that diagram. Identifying the right angle triangle from the diagram, we have formed a right-angled triangle OAP, where OA is equal to x, AP is equal to y, and OP is equal to r. Since the angle at A is 90 degrees, we can apply Pythagoras theorem. Applying Pythagoras theorem. I would like to remind my viewers and all the members of the internet who like doing mathematics that I've already have a video on proving the Pythagoras theorem. So just go over my channel. In a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. That is the Pythagoras theorem. In simples, if a triangle has sides A and B and hypotenuse C, then C squared is equal to A squared plus B squared. Applied to our triangle OAP, OP is equal to R, which is hypotenuse, OA is equal to X, AP is equal to Y, so OP squared is equal to OA squared plus AP squared. Substitute the values. R squared is equal to X squared plus Y squared. Rearranging, this directly leads to the equation of the circle X squared plus Y squared is equal to R squared. Distance formula, and here we are revising. If a point A is xy and a point B is hk, then the distance from A to B is equal to the square root of x minus h squared plus y minus k squared. This formula is the foundation of the equation of a circle. So, the standard form of the equation of a circle, if a circle has center hk and radius r, the equation of the circle is x minus h squared plus y minus k squared is equal to r squared. And we have a special case where the center is at the origin, and if the center is at the origin, that is 0, 0, the equation is x squared plus y squared is equal to r squared. And the general form of the equation of a circle is x squared y squared plus 2gx plus 2fy plus c is equal to 0, where the center is negative g, negative f, and the radius is the square root of g squared plus f squared minus c. Square root of g squared plus f squared minus c. Key points to remember. Always compare with x minus h squared plus y minus k squared equals r squared, where x and y and h and k are 2 points along the line we call the radius. Radius is always positive, and completing the square helps identify center and radius, as you very soon see. Common exam mistakes include forgetting to square the radius, wrong signs for center coordinates, and incomplete completing the square steps. Now, members of the internet, we will now apply the equation of the circle after knowing how to prove it. So, our task is finding the equation of a circle. And in case 1 is where we are given center and radius. Example, given the center 3, negative 2, and radius 5, the equation will be very easy because you just substitute in the general equation and you get, if 3, negative 2 is the center, you have x minus 3 plus y minus minus 2, which becomes y plus 2 squared, is equal to 5 squared, which is 25. Case 2. Given center and a point on the circle, the steps are as follows. Use the distance formula to find the radius, as indicated earlier. Substitute in the standard equation, and we have an example here. You have center is 1, 3, and the point on the circle is 5, 6. Therefore, the radius will be 5 minus 1 plus 6 minus 3, each squared, is equal to 16 plus 19, which is equal to 25. So the equation is going to be, when you take the center, x minus 1 plus y minus 3 is equal to 25. Now, this is a question directly picked from our past KCSE paper, the Kenyan Education System. And I hope wherever you are, in which country, you do the same things. A circle, center C5, 5, passes through the points A, 1, 3, and B, A, 9. Find the equation of the circle and hence possible values of A. The center of the circle is C5, 5. Step 1, find the radius using the point A, 1, 3. Therefore, r squared is equal to 1 minus 5 plus 3 minus 5, each squared. You get r squared is equal to negative 4 squared plus negative 2 squared, which reduces to r squared is equal to 16 plus 4, which is 20. So the equation of the circle is x minus 5 plus y minus 5, that is subtracting the coordinates of the center, each squared is equal to 20. Now, step 2. Using point B, A, 9 to find possible values of A. Since B lies on the circle, its distance from the center must also be 20. And therefore, since the center is 5, 5, the equation will be A minus 5 squared plus 9 minus 5 squared is equal to 20. That is applying the equation of the circle. A minus 5 squared plus 4 squared, because 9 minus 5 is 4, equals 20. A minus 5 squared plus 16 is equal to 20, because 4 squared is 16. A minus 5 squared is equal to 20 minus 16, subtracting 16 from both sides, and therefore you get A minus 5 squared is equal to 4. Taking square root on both sides and simplifying. Therefore, the square root of A minus 5 squared is A minus 5, and the square root of 4 is plus or minus 2. So A minus 5 is equal to plus or minus 2. We take the positive root, and we have A minus 5 is equal to plus 2 implies A is equal to 2 plus 5 equals 7. That is, we add 5 to both sides, and all A minus 5 is equal to negative 2 implies A is equal to negative 2 plus 5, which is 3. And therefore, A is equal to 7 or A is equal to 3. And the final answers are, equation of the circle is x minus 5 squared plus y minus 5 squared is equal to 20. And the possible values of A are A is equal to 3 or A is equal to 7. Now, let us go further, converting general form to standard form. And the method we are going to use is completing the square. And you can see working on completing the square in my previous videos on the quadratic equations. So our example is x squared plus y squared minus 6x plus 4y minus 3 is equal to 0. Is a general form of an equation of a circle. So the first thing we do is we group x and y terms. And that is the first step when completing the square. So you have x squared minus 6x plus y squared plus 4y is equal to 3. When we take 3 to the other side. Completing the square by adding a half coefficient of x and y to both sides. So we have on the group of x, we have x squared minus 6x plus a half times negative 6 squared, half coefficient of x, plus y plus 4y plus a half times 4 squared. 4 is the coefficient of y. And if you have done that to this other side, you do the same to the other side. So you have 3 plus a half times negative 6 is negative 3. And when you square negative 3, you get 9. So you add 9. And then a half times 4 squared. A half times 4 is 2. And 2 squared is 4. So you also add 4. So on the right side, we have 3 plus 9 plus 4. Therefore, our equation, we simplify, we'll get x squared minus 6x plus negative 3 squared. That one is a perfect square now. Plus y squared plus 4y plus 2 squared is another perfect square, is equal to 16. That is the 3 plus 9 plus 4. Factorizing perfect squares of x and y, you get x squared minus 6x plus negative 3 squared. The factors are x minus 3, and therefore it will be x minus 3 squared. And for y squared plus 4y plus 2 squared, the factors are y plus 2 squared. And because they are perfect squares, they are the same. And this gives you 16. Now, that is the standard way of writing the equation of a circle. So from there, we pick the center as 3. And from the x minus 3, we pick 3. And from the y plus 2, we pick minus 2. And therefore, the radius will be the square root of 16, which is 4. Practice questions. Question 1 is, find the equation of a circle with the center negative 2, 4, and the radius 3. Question 2 is, find the center and the radius of x squared plus y squared plus 8x minus 6y plus 9 is equal to 0. Question 3, a circle has center 5, 5 and passes through 1, 3. Find its equation. So here, I've given you the answers only. You try the working. Question 1, the answer is x plus 2 squared plus y minus 4 squared is equal to 9. And if you work also well in equation 2, you get the center as -4, 3, and radius 4. And finally, number 3, the equation will be x minus 5 squared plus y minus 5 squared is equal to 9. Notice that you don't work from the answers. You work first and then you look at the answers. In conclusion, therefore, we have proved that the equation of a circle with the center at the origin and radius r is x squared plus y squared is equal to r squared. This equation comes directly from distance and Pythagoras theorem. Exam tip. In mathematics exams, always draw a neat diagram. Next, clearly show the right angle triangle. And number 3, state Pythagoras theorem before substituting so that this earns you full method marks. This brings us to the end of today's lesson on the equation of a circle. Please practice the questions given and revise your notes. If this video helped you, like, share, and subscribe for more mathematics tutorials. See you in my next